We're going to be working a lot with digital audio, so it's worth taking a moment to discuss what exactly digital audio is. In the natural world, sound exists as waveforms. When we record sound to a computer, we have to convert those waves to ones and zeros. And when we play it back, we've got to convert the ones and zeros back to waves so that we can hear it. The way we do those conversions can have a drastic effect on the quality of the sound. Let's take a look at this guitar region. I'll play it for you. Now, when we look at it at this resolution, it just looks like a lot of mush together. But as we zoom in, you can see the waves start to take shape. And this is Pro Tools' representation of this sound. Look as I scroll through. You can see the wave. I can zoom in even closer. And you can see the wave going up and down. The shape of this wave determines the sound that we hear. Let's take a look at a simple wave, a sine wave. I'll turn on my sine wave here, and you can see in the oscilloscope the patterns of the sine wave. As I raise my frequency up, you can hear the pitch go up. And as I lower the frequency, the pitch goes down. The frequency of a wave determines pitch. Now, as I increase the level, let me turn my frequency back up. Now watch when I increase the level. The waves get bigger, and when I shrink the waveform down, the waves get smaller. The height of the wave, or the amplitude, determines loudness. Now, when we create a new session in Pro Tools, we get asked two questions. What is the sample rate of the session, and what is the bit depth we should use for this session? Let me explain what those are. Here's our sine wave again. In Pro Tools, we have to convert it to ones and zeros. To do that, the computer is going to take a picture of the wave on a regular basis. Or another way of saying this is that the computer is going to sample the waveform at a given rate. If the rate is low, then we don't take a lot of pictures or samples. And when we compare what we get to the actual waveform, we don't have a really great representation of the wave. The more we increase the sample rate, the better a picture we will get. In other words, the higher the sample rate, the more the computer's representation of the audio matches the real audio. Depending on your audio interface, you will have different options for sample rate. The most common are 44.1 kilohertz or 44,100 samples per second and 48 kilohertz or 48,000 samples per second. Now, the other thing we are asked for is bit depth. Bit depth determines the precision of the amplitude value stored in the computer. The higher bit depth, the more precise the computer is. Think of it like rounding numbers. The more decimal places you use in a number, the more precise the number is. Many old computer games use 8-bit audio. That meant that there were only 256 numbers to use when describing the amplitude of a wave. That sounds like a lot, but it's very imprecise. It did give those computer games a unique sound quality, which many musicians still like to replicate today, even though we have equipment that works at much higher bit depths. Today, it's most common to use 16 bits or 24 bits. A bit depth of 24 gives us nearly 17 million values to describe the amplitude of a wave. This means that you get a much better representation of the audio, but it takes 50% more hard disk space than 16-bit recording. Bigger numbers, more space. Compact discs use a sample rate of 44.1 kilohertz and a bit depth of 16. So if you're working at a different sample rate or bit depth and want to get your audio onto CD, it will need to be converted. Fortunately, Pro Tools makes it very easy to do that. However, since disk space is cheap, it's usually better to work at a higher bit depth and a higher sample rate. This lets you record at the highest quality. Additionally, all the calculations that Pro Tools does when applying effects or other processing are much more precise. The end result is that your audio sounds better even when you convert your tracks to lower sample rates and bit depths for the CD.